Thank you, and thank you, John, for the introduction to chaparral and fire. And really, if you heard his talk, you don't need to listen to mine, but I'll give it anyway. My colleague Marcia Nera, co-author out here, did a lot of the work on this project, and Bonnie Corcoran, who's sitting back there in the audience, collected most of the data, so thank them. As John just told you, chaparral is widespread in California. It's a evergreen, shrub-dominated ecosystem, covers many acres in Southern California and also in low elevations in the Sierras and other foothill areas. It burns in crown fires, pretty much a crown fire, or it's not burning at all, either through prescription, as shown in this picture, or in wildfires. So nice tall flame lengths. And afterwards, it's pretty much scorched earth. Everything burns up. But chaparral is well adapted to fire, as John mentioned, to particular fire regimes. And this is a sort of introduction to the responses, although he gave that already. Some people must have come in and didn't hear his talk. Species we consider obligate sprouters generally do not reproduce from seed after fire, but they sprout vigorously. Things like toyon, the various scrub oaks that occur in chaparral. And then there's a whole suite of fire-following herbs that appear after fire. Phacelia species are one of the predominant, genera. Formerly known as lotus is acrospon, lupinus, and a lot of other ones. And then there are shrubs which are considered obligate seeders. They only recover after fire by seed. Many species of Ceanothus fall in this category, also some manzanitas like Staphylos. And then other shrubs will do both. They sprout and they produce seedlings. Chamise, the most common probably chaparral shrub, is in that category. Also a number of Ceanothus and Staphylos are in that category. So this is just some pictures of first growing season. It's really not even a year after the fire. The top, I don't have a pointer, but all right, top is a resprouting scrub oak, and then in the lower left you've got some fire-following herbs, and then on the right little seedlings of Ceanothus and adenosoma, chamise. Okay, that was San Diego County, where it was fairly dry. In coastal Santa Barbara County, this is also the first growing season after fire. It was a particularly good rain year, nice evenly spaced rains, and the post-fire vegetation just went crazy. The tall purple stuff is large flowered Phacelia grandiflora. Amazing plant. This tall already by March. And then the white flowers are Chalcedonia. So you can get quite a lot of ground cover, and John showed you that when that dries out, it's actually pretty good fuel. However, a lot of our chaparral is near areas that are disturbed and contain non-native grasses and forbs. These are data from a study that I was involved in a number of years ago. We were looking at the effects of ryegrass seeding on chaparral recovery. But the black bars are aliens, those non-native grasses, predominantly red brome and avena. And you can see that the first year post-fire, you don't get most of those non-natives, but then they start coming in, and you get a little bit the second year, fair amount the third year, and for the fifth year after fire, you can have a pretty good stand of non-native grass, especially in systems that are dominated by the obligate seeding Ceanothus, which this site was. It was one that mostly had big pod Ceanothus, so while those little shrubs were recovering, there was plenty of open space for the non-native grasses, and those also greatly increased the fire hazard. In fact, this site burned in the fall of 1993. This is just a picture of that. This was a study that we did. You can see the kind of brownish stuff. I wish I had a pointer, but there's some red in there. That's all red brome growing in amongst the chaparral. All right, so all this reddish in here, that's red brome and some other non-native stuff. So there is this nice flashy field bit that's in young chaparral. Okay, to the data. We studied the Esperanza fire, which burned in October of 2006 in the foothills of the San Jacinto Mountains. 16,000 hectare fire, overlapped 10 previous fires, and the purpose of the original study was to look at the effect of different burn ages on chaparral recovery. We predicted that the younger stands would probably have more non-native grasses coming in because some of them still had a lot of that grass in the system when it burned, and to see what the effect was on seedling regeneration, particularly of the seeding Ceanothus out there, which used to be Ceanothus gradii, and I guess it's Ceanothus perplexans now. And we set up plots which were 20 meters by 20 meters, had 5 20-meter line point transects to get cover, and then counted seedlings in belts or quadrats along that. And what we found was that stand age really didn't have much effect on either the amount of cover that was produced after, this is after 3 years, pretty much all the sites recovered, they had good stand cover, and also fire severity. We had done an assessment of how hot the fire burned in each of these individual plots, which is 65 different plots. And so neither fire severity nor stand age had an impact on total plant cover after 3 years. Everything seemed to be recovering, although species composition was different. We expected that there would be more grass cover in the younger stands, but really there was no relationship. Stands of any age after 3 years still had a pretty high component of the non-native grasses. And part of the reason for this probably is that there was a good seed source. There's an extensive fuel break system in the study area, which was in the North Mountain experimental area. And you can see one fuel break along here. And then this is part of one that hasn't been cleared for a while. There's a lot of eriogonum and sages and stuff that have come in, but there's lots of grass in there too. So the grass is pretty much to get to all the plots, and I think that's part of why we had so much grass cover. In the plots that had more resprouting shrubs, the shrub cover increased faster, so there the grasses got shaded out faster, and so there is definitely a relationship between shrub cover and grasses. We also counted seedlings, and as would be expected from what John told you, in the younger stands there were not a whole lot of Ceanothus seedlings to be found. The middle-aged stands tended to have more. It was not consistent. And then we had a few stands with, it says 120 years since the last fire. That was just an arbitrary number. We didn't know when the last previous fire was. There was no recorded fire history for those places. There weren't a whole lot of Ceanothus seedlings in those stands either. So that was the first fire. Then in 2013, the silver fire reburned part of the area where we had our plots. And Marcia and Bonnie went out and relocated 8 plots that had reburned that we had data for, and then also 6 plots that burned in 2006 that we actually collected data on, that, or 5 of them anyway, and that burned in 2013 for the first time. And so we decided to compare recovery in those. Can you guess which plot is the reburned and which is the one that burned for the first time? Pretty obvious. A lot of mustard in the reburned plot, and this was one that wasn't even sampled in 2006 because the vegetation was so dense nobody wanted to walk in there, and it pretty much burned to the ground. So results. Total cover was much higher on the reburned plots than on the silver fire only plots. This was measured in May. And that's species richness was also a bit higher. And that's predominantly because there were a lot more non-native grasses coming up in the reburned plots and more non-native forbs. The main forbs in those plots were Cimbrium altissimum. I can't remember the common name for that. rocket, and Hirschfeldian canna, the short-pied mustard. Native fire followers, however, were abundant in both kinds of plots. This category is a mix of both what would be considered obligate fire followers, like the Phacelia species, and then opportunistic things like Cryptantha and some of the lupins that have come up anyway. This is a reburn plot that didn't have a lot of mustard and on it, or grasses, so they weren't all type converting. This shows a manzanita, East manzanita, resprouting. When it burned in 2006, the plot it was about 78 years post-fire at that time, so you had some really big stems, it must have been a magnificent manzanita. Burned down in the next 7 years, resprouted vigorously, and then burned again, and here are the new resprouts. And I'll be curious to see if they suffered reduced vigor because the burl being drawn on so close together. Interestingly, the manzanita on these plots was all attacked by some kind of a bug that affects the leaves. So there's, anybody know what that is? I saw a talk on it last time. Yeah.
Leaf galling.
Yeah. So these all had that, and we'll see what the long-term effects are. This is one of the initially burned plots, and in terms of seedlings, we only got good CNPS seedlings in the plots that were oldest at the time that they burned. And it turned out that a lot of the plots that didn't burn in the Esperanza fire were only 7 years old at the time it went through. That's why the fire might have gone around them. It was hit when the Santa Anas weren't blowing. And then all these zeros are the reburn plots. So, as John mentioned, is this going to become that? On this particular site, certainly it looks like CNPS perplexans density is going to be lower than it was before the Esperanza fire. Some areas that had CNPS perplexans are not going to have it anymore, probably. The sprouters all seem to be doing well, however, so it's going to take more than just 2 fires in quick succession to knock them down, but it'll be interesting to see how all those aphids affect the manzanita. Most of the herbaceous fire followers did pretty well, despite the fact that it was a really dry winter last year. And so we see species composition shifts occurring, but type conversion is not quite there yet. We'll see with time. And that's the end.